palangga. It's chemistry time sa kadlaw. Oh my gosh. O, diba? Okay, muna kita wag chemistry sa kadlaw. Charot. Okay, mga palangga. Ang hitad. Okay. Wait for a while, mga palangga. Hitad. Okay. So, atong topic karon is it's gonna be saman charot atomic size and ionization energy ganon, diba? Wait for all mga palangga. So ganon. So ano na siya. Ganon. So, mag-isip lang ta. So, uy, sige, ako na isuwat dari ari. So, man ako siya text. Okay. Ganon. Layo juga kayo guys. Hello. Hello mga palangga. Okay, so ang buhaton is to explain again, right? Okay, sa kadlaw. Sa kadlaw, explain ko dyan ko, diba? So, anak siya. Okay. Okay. So, nakakaroy ko we have here, say for example, atomic, okay, atomic size versus ionization energy. Ganon. Diba? Okay. Okay. So, ionization energy is an energy required to remove an electron from a gaseous state, or not limited only to gaseous state. It could be also solid, liquids, or whatever. Okay. Okay, now we have, for example, we have here carbon, we have group 4A. Group 4A in our periodic table, we have carbon, okay, silicon, germanium, charot. Okay, tin, right? And we have also lead. Okay, atomic mass of carbon is 12. Atomic mass of silicon is 28.28. I don't know with the germanium, I forgot. Okay, 10 is gonna be 180.7. And I have the lead 207.2. Okay, so as you can notice, atomic mass is increasing. So it's gonna be, but I don't know with the germanium, we not memorize. But I'm sure germanium is a metalloid or a transition element for sure. I think it's okay, something like that. Now, if we try to arrange this in terms of decreasing ionization energy and decreasing atomic size and increasing ionization energy and increasing atomic size. So we need to relate this in that way. Okay. So relationship mga palangga. So if we have, for example, if we have a very big ball, something like that, and then if that is very, very big, so the electrons are not held closely toward the center. Okay, meaning to say the electrons, particles are really far away from the central nucleus, and then, we have less ionization energy for that. But, okay, because it's too big. But if the ball is very small, okay, then we need strong ionization energy, because the more it is small, the electrons and the particles are very close to the nucleus, and it's very attracted to the center, and we need to it's very difficult to remove the electrons. Okay, that's why we need strong ionization energy to remove the electrons away from the central nucleus within that ball. So that's the analogy. Whereas if it's the big ball, then the electrons are far away. Okay, something like that. Okay, so the more the atom is really going to be big, something like, or the shape to be big, the size or the shape to be big, the lesser the ionization energy it requires. The more it is small, the atom and the element, the more it is really needed a strong ionization energy. So we can say, mga palangga, that atomic size, okay, like that, is inversely proportional to the ionization energy. Ganon. Okay? Now, if my question here is like that, from the top to the bottom of the periodic table in the group, so we can say that there will be an increasing, size of the element, because there's an increasing list of the elements. Since we know also that the atomic number also is increasing, and at the same time the molecular weight also is, not molecular weight, the atomic masses of the elements are also increasing, the mass number is also increasing, something like that. So it's gonna be from top to bottom. Okay, the size of an element or the atoms in that will be going too big, something like that. And I have to illustrate here. I will say, I could not draw properly because my whiteboard is very small. Okay, it's gonna be like this. Da-da-da. Okay. Da-da-da, 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 ganon. Okay, so small circle, big circle, ganon. Okay, so for example, mga palangga, kung hitacha, okay, if we have the carbon, this is in the second level, carbon, second level, silicon, third level, germanium, fourth level, 10 is 5, and lead is 6. Okay, this bigger corresponds to the lead, a little bit bigger corresponds to the tin, and then this one corresponds to the germanium, like that, silicon, like it's in carbon, right? Come on. So let's do the electronic configuration for this. Okay, and then charots. If we have n is equals to 2, so we need a 2 like this. Da-da-da, ganon. Okay, like this. Because this is n is equals to 2, n is equals to 1, n is equals to 2. Okay, then we need to determine the atomic number of carbon, which is 6. Atomic number of carbon is 6, equivalent to 6 number of protons also, because the number of protons is equal to the number atomic number. Okay, so if I have 6 protons, ganon, okay, it will be just equal to the electrons automatically, because it's going to be talking with the electrons also, the atomic number directly. Okay, so it will become charged during the transferring of the electrons of a certain atom. That's why. Okay, like this. So I have 6, right? As I told you a while ago, atomic number 6, right? Okay, so like that. We need to fill this by electrons. Okay, the outermost shell is this one. Okay, since we have 2 energy levels, so we have 2 circles. 1 circle, big circle, and the outside circle will be the outermost shell, which is equal to 4 valence electrons, because carbon is in the group 4A. Okay, 4 valence electrons. So in the inner core, okay, level or shell, how much? Since let's assume 2, because there's 6, right? So 6 plus 2, 8, valence 4 and 2 in the first energy level. Second energy level outermost shell is 4. How can we prove that one? So electronic configuration. So 1s, 2s, 3s, ganun mga palangga. 4s, 2p, 3p, 4p, okay, 4s, 4p, and 5f. Okay, I feel cold. I need to off the AC. Okay. Okay, guys. So, so it's gonna be like that. The electronic configuration, this is the off-ball principle, so that we can get the electronic configuration. Okay. So 1s, 2s, 3s, 4s, 2p, 3p, 4p, 4s, 4p, 5f. Okay. Our goal here mga palangga, is to determine the atomic size of each element, how it will become bigger and bigger and bigger and bigger. So the main concept here is, if we have first energy level that is small, second energy level, it will become a little bit bigger, third energy level, it will become a little big, 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 so and so, until it will reach too much big if the energy level is too much high. In this case, for carbon, we need only 2 energy level, okay? Like that. So 1s, 2s, ganon. O, diba? Mapalanda akong hitad. Okay? Ganon. So, electronic configuration, we have 6, okay? Protons or atomic numbers. So we will say 1, this is for carbon mga palangga, ha? So 1s, 2, 2s, 2, and then after sa 2s, 2p na yung mga palangga. Now, we have 6 protons, atomic number. So, okay, we have 2 electrons will occupy to the s orbital, 2, maximum 2, and p is also 6. Since we have only 6 total of protons, so we cannot put 6. We need to add only 2. 2p, 2 is the last for carbon. Okay, ganon. Good. First level is 2, right? So there's 2. 1, 2. Okay. And then this one is 2. Okay. So second level siya. 1, 2. And then the valence electrons is 4. We have to count the last, configuration. Okay. 1, 2, 3, 4. So this is we have here. 1, 2, 3, 4. Okay. So 4 plus 2, 6 electrons in a second energy level. Okay. Now we go to silicon. Okay? Silicon. Tapos nakasakuan sa carbon. Let's check if the size will be bigger and bigger, ha? Okay. Silicon. So we have mga palangga ulitan, 14. So ako sa iris, 1s, 2s, 3s, 4s, okay, 2p, 2, 3p, 4p, okay, 3s, 3p, and 4f. 1s, 2s, and then ganon. So we have 14. So 1s, 2, 2s, 2, ganon na nga palang akong hitad. 2p, 6, 3s, 2, and we have 14, right? 10 plus 4, 12 pa siya. Then we have 3p. So 10, 4 plus 6, 10, 12. So we need 3p1 na siya talaga mga palangga, ha? O diba? Ganon. So, our silicon, this is, I have no space na talaga siya, guys. Uy, okay, nakakalo ka. Diba? So, I need to show the silicon here. Okay. Mag-draw kong silicon. Charot! Okay. So, we have 3 energy levels. I have to do 3 circles. 1 circle, 2 circle, 3 circle. Ganon. So, our inner number of electrons in the central atom, okay, because it's in the nuclear, in center nucleus. So, we have, okay, 1s, 2, 2s. So 1s, we have 2 electrons. Okay, this is n is equals to 1. 2 electrons. Okay. The second energy level, Okay, like that we have 8, right? 8. Okay, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, sa last two, we have 3 sa outermost shell, right? Let's check if it is 14. Okay, 3 na lang siya. Ano ko lang kakita, di ba? Okay, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 3 na lang siya sa outermost. 1, 2, 3. So pila tanan? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So sakto siya, 14. Ganon. So take note guys, if you try to compare the silicon and the, silicon and the carbon, so the silicon is bigger than the carbon. Okay, like that. Since the center is the nucleus and the center also is the nucleus, something like that. Now, we have electrostatic forces from each orbital, right? F, ganon. F, electrostatic forces. F, ganon. Okay, now, okay, the electrons are much farther with the nucleus in terms of silicon compared to the, the carbon. So, meaning to say, the carbon is very strong electrostatic forces. Okay, now, you cannot pull directly the electrons toward the center of the nucleus in terms of the silicon. Okay, it's very far, then the electrons are very far apart. Okay, so if the electrons are very, very far apart in the nucleus, then we don't need much ionization energy because it's very far. So, okay, it's very easy to remove the electrons, okay, away from the nucleus. So, since it is very easy to remove the electrons from the nucleus, then you need less ionization energy. Because ionization energy is the energy required to remove the electrons from the atom. Now, so since carbon electrons are very near in the central atom, okay, so there's a very strong electrostatic forces of that electrons very close to the nucleus, then it's very attractive with each other, then we need too much energy to remove the electrons with a smaller distance from the nucleus, which is the smaller atomic size element, carbon. So meaning to say, the more it is having a smaller distance, okay, near to the nucleus, the more it is difficult to remove the electrons away from the nucleus because it's very near. There's a very strong electrostatic forces. Okay? Now, if the circle is very big or the atomic size is very big, so the electrons are very far with each other, so we don't need much extra effort to remove the electrons away from the nucleus. That's why carbon has a higher ionization energy compared to the silicon. Okay, until it will go down because this germanium also will occupy in the fourth energy level, 10, meaning TIM. Okay, 5 energy level, lead 6 energy level. These numbers represent the circle, small circle, like that, circle, 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 and then, okay, if 5, meaning 5 circle, ganun. If 6 energy level, 6 circle, ganun. So magkadako, we have a bigger atomic size, okay? If magkadakong atomic size, lesser ang ionization energy. If gamay ang atomic size, meaning to say strong ionization energy, we need to remove the electrons away from the central atom. So how can we put the relationship here? So it's gonna be like saying, okay, it's gonna be like saying that, okay, atomic size is inversely proportional to the ionization energy. When the atomic size will increase, okay, we need less ionization energy. If the atomic size will decrease, we need a very, very strong ionization energy or high ionization energy. So inversely proportional. So if the question, for example, in the examination or board examination, for example, especially this is related mostly in the, chemistry principles or physics like that. Chemistry, really. Okay, so how to arrange that? Arrange these elements according to increasing ionization energy. How can you do that? Carbon, silicon, germanium, tin, and lead. The question is arrange these elements according to the increasing ionization energy. You will say, okay, you will start from the bottom. Okay, increasing man siya. You get the point? Okay, because carbon has a higher ionization energy, so we will start with the smaller ionization energy. So we will say Pb, okay, ionization energy is less than 10. Tin, ionization energy of tin is less than germanium, okay, and then silicon, okay, up to carbon. So meaning to say the ionization energy of tin is greater than lead, the ionization energy of germanium greater than tin, the ionization energy of silicon is greater than germanium, the ionization energy of carbon is greater than silicon. So this is in the increasing order. If the question also will say arrange the ionization energy in decreasing order, we will start also with carbon. Okay, carbon is greater than, silicon, is greater than germanium, is greater than tin, and is greater than lead. So it depends on the question, something like that. Okay? Now, for the atomic size also, we will say, in here, the atomic size mga palangga, okay, going down, okay? As it goes down from the top of the bottom, from the top to the bottom, so your atomic size will increase based on the energy level, the row, the family. So it will become like this, guys. Okay, arrange the atomic size in decreasing order. O, ganon. So we'll start with the lead. Okay, like this. And then, ganon, tin. This is decreasing order of atomic size. Germanium, silicon, and carbon. So arrange these elements according to the increasing atomic size. So you will start with the lead, okay, increasing, ganun, this one, and decreasing, start with the higher atomic size or bigger atomic size. Carbon, okay, greater atomic size than silicon, silicon greater atomic size than germanium, germanium greater atomic size with tin, and tin is greater atomic size with Pb, like that. Okay? So you can arrange now in that way. Okay? Like that. Okay. Because of this relationship only. During your review or study, okay, you need only to determine the relationship. Something like that. Okay? But this is all about from the top to the bottom of the periodic table. How about from left to the right? Something like that. Okay? Which is the row. Because this is the the group, vertical. Okay, let's say we consider the mga palangga kumplitad. Okay, let's say I will consider the charot. Okay, lithium lang. Okay, lithium. Okay, lithium, beryllium, boron, charot. Okay, and after boron we need to say carbon. Okay, phosphorus. Wow, phosphorus. Jump. Kaloka. Oxygen. And then we need to have, I think it's gonna be fluorine. Okay, like that, fluorine. Okay, so this is now in a horizontal. In the same energy level na talaga siya. Okay, let's say this is in N3. Okay, N3 ba niya siya? N2, second level. Energy level 2. Okay? Ito yung mga point mo palangga. Okay? So let's say, this is just an example because I cannot memorize everything the arrangement of the elements in the previous table. This is just try to imagine that this is in the second level, but I think also this is in the second level. Correct me if I'm wrong. Second energy level. Okay? The row with the family represents the energy level of your, of your electronic configuration, something like that. Okay? So how can we say that who among them have a higher ionization energy. Still, we will use that relationship also. Atomic size is inversely proportional to ionization energy. Then how can I relate the arrangement for this? Okay, I must say that the ionization energy will increase from left to the right. The arrow will go here. Okay, from left to the right. Okay, this is ionization energy. Ganun naman pala ang taong hita, diba? Now, your atomic size will be in reverse from right to the left. Is increasing. This is your atomic size. Okay? Ano pala ang taong hita? Charot. Okay? It's gonna be like that. So, the atomic size is gonna be like that. Okay? Okay? Because the ionization energy is reverse to the atomic size. Okay? Ganun siya. Now, let's just imagine, we cannot say the same story before because they are on the row. Okay? We will just say like this, okay, small circle, big circle, big circle, until such that it will become bigger and bigger. Because increasing my atomic size. Okay? Let's go direct because it's just totally the same. Okay? You get the point. If we try to determine also the electron configuration, it will take us a very long time to get the electron configuration of fluorine, oxygen, phosphorus, carbon, boron, helium, and lithium, something like that. But we can make it, but it will take a longer time. Let's just analyze and follow the theory that the increasing atomic size will start from the right, the fluorine, like this, smaller, a little bit smaller, until increasing size going. Meaning to say, the lithium is the biggest shape. Secondary is the beryllium, and the next is boron, and then carbon, phosphorus, oxygen, and fluorine. Fluorine is the smaller one. Now, this is atomic size. Ionization also is the reverse, the relationship. Now, small, as I told you before, the smaller the element will become, it will need a higher ionization energy, in which the theory also, match with the illustration. Okay? It needs a very strong ionization energy to remove the electrons away from the central nucleus of an atom, of that element, because they are very, very strong, attractive electrostatic forces between them. I need to remove the electron because that is the definition of ionization energy, is an energy required to remove the electrons, okay, away from the central atom, okay, in a solid, liquid, or gas, something like that. Okay, get the point. Muna siya nahitabo. Okay, so it's gonna be like that. So, meaning to say, fluorine has a higher ionization energy compared to oxygen. Oxygen has a higher ionization energy compared to phosphorus. Phosphorus has a higher ionization energy compared to the carbon. Carbon has a higher ionization energy compared to boron. Boron has a higher ionization energy compared to beryllium, and beryllium has a higher ionization energy compared to lithium. Okay, if the question in the future in the board examination will say, or any examination pertaining to general chemistry lecture, it will say arrange these elements according to the decreasing ionization energy. So you will start with the highest ionization energy, increasing siya. So we will say in descending order, starting from a very strong ionization energy, a high ionization energy, to the least ionization energy. I will say, okay, fluorine, ganon. So it's decreasing. The arrow will be ang decline sa back arrow, so ano ito pa dun sa right, kay sermon siya, less than, right? In math, in elementary mathematics, I think grade 3 or grade 4 in elementary level, our teacher told us the greater than, the less than, something like that, the symbol, the equal. So we should also apply here up to college, something like that. Okay, so the less than, okay, ang pinatumoy sa arrow dito sa left, ang ayang right katong ng buka. Okay, so fluorine, so fluorine, ganun siya, oxygen, sunod din, phosphorus, di decreasing order na siya. Okay? Mga siya guys sa mga question, descending order, decreasing order, ascending order, increasing order. So here, we need to arrange in descending order according to the ionization energy. So we mean we start with a higher ionization energy of fluorine. Secondly, oxygen. Thirdly, phosphorus, ganon. Carbon until such time going to boron, beryllium, and lithium. Because lithium has a very, very low ionization energy. If the question also will be modified, say, arrange these elements according to the increasing, ganon. So you will start also with the lowest ionization energy, lithium. But your symbol also, the buka, yang kanon ang lithium. Di bali ang buka, ang iyang katungtong mo ito, dito pa nung sa right, muna siya ang symbol sa greater than. Ganon. So we will change this one. So lithium, okay, kamay na siya, okay, so increasing order na siya, so gano'n siya may tago. Okay, gano'n siya lesser than, okay, and then, pagulong sa taas. So, okay, get the point. So, arrange increasing order and increasing order. Okay? Because fluorine has a very, very high ionization energy. Okay? Ganun siya. So, arrange increasing order, mag-start ka sa fluorine. Bali. Increasing order, mag-start ka sa lithium. Okay? Ganon. The arrow, mabalik na siya. Greater than na itong ika-away with 2. Okay? Ano siya guys ha? Kung tayo have the same energy level. Ganun siya. So in short, we can say in this way, actually, I know na this board is not enough from the discussion talaga. I have to shortcut. Okay? Okay. So I can say directly the relationship of ionization energy and atomic system. I can say directly that, the ionization energy will increase from the top, okay, going to the top, from top, bottom to the top, and then from left to the right, and then diagonal going also here. Okay, so there are also elements somewhere along the way here. You can also arrange according to the ionization energy. This is the arrow pointing up, okay, arrow pointing to the right. So this is representing the periodic table. Here left to right, top to bottom, and here our basis is the fluorine, which is the electronegative, the most electronegative element in the periodic table. Okay, out of 118 elements in the periodic table, fluorine is the most electronegative. Okay, meaning to say this fluorine is very hungry all the time. Pero siya gutomon of electrons. Okay, and then he will ask these electrons from the metals group from the left. Okay, something like that, because these metals from the left, okay, are mostly electropositive, and then you try to give these electrons to the right side, and the most hungry of all, hungry ba siya or hungriest, is the fluorine. That would be our basis. Okay, so if the question also in the future will say, which is the most electronegative element in the periodic table, your answer will be fluorine. Okay? When ilain, fluorine is the most electronegative element out of 118 elements. Right? If you can remember our, in our chemistry in high school, I still remember that we have at least 94 elements that are metals, and I think also there are also 17 nonmetals, and we have also 38 radioactive elements. Okay? So, okay, since, we need to memorize sometimes so that it can, accumulate in our brain cells. Okay, as we grow older. Charot! Okay. Nakakaloka. Okay, now, if this is our ionization energy, and we have also the atomic size. The atomic size, mga palangga, is reverse. Okay, from top to bottom siya. Ganun siya talaga. Ganon. Okay, so, ganun siya. Okay, ang atomic size. Mag-increase ang atomic size padulong sa bus. Okay? Then padulong from right to the left, mo-increase ang imong atomic size sa row. Okay? Right to the left. Ganon. Top to the bottom. And mubalik po din imong diagonal. Okay? So we need to say, as I said over and over again, atomic size is the reverse of ionization energy. Okay? Or inversely proportional with ionization energy. Okay, ganon. So that we can summarize this in another properties also in the periodic trends, that is periodic trending or periodic trends, periodic table, something like that. So we need to introduce another properties. I think there's a lot, guys, and I don't have to do that one by one, right? Because the concept is just more or less the same. Okay, but there are also exceptions for this rule, but we cannot encounter because I cannot memorize all elements. I memorize only up to 60 plus elements in 118 and all the atomic numbers or atomic masses, but I cannot memorize everything about atomic masses also. Okay? Like that. You get the point? So, ganon. Okay. So, muna siya ionization atomic size also mga palangga. Okay? Now, there are cases also, guys, that you can say, especially the issue in the horizontal row or in the family. Okay, I will say this. I need to discuss this. That the row in the periodic table, row, horizontal. Okay, the row represents the family. Okay, or a period. Okay, you will say these elements occurring in the same energy level or shell. Okay, like that. And then the vertical is the group. Okay, like that. Okay, so the family period as per energy level, okay, n is equals to 1, n is equals to 2, meaning the circle, chuba, chucho. N is equals to 1 circle, and n is equals to 2 circle, n equals to 3 circle. So in that circle, chuba, chucho, so many elements will occur there like this, lithium, helium, like this, and then the second like that, and the rest will follow. Okay, but in the group, okay, not like that. Okay, something like that. Okay, so muna siya nitabo. Family period katong sa row, and the group is katong from top to the bottom. Muna siya ang group. Okay, so di ba guys, atong hinumduman the group chuba chuchu, di ba? Group 1A, okay, 1A, and then 2A, ganon to chuchu, group 2A, and ganon, we have the group 4A, 4, 5, 6, 7, 8, ganon, 4, group 4A, group 5A, group 6A, group 7A, ganon, and group 8, okay, group 8A. Okay, so we need to classify this grouping chuba chuchu. Okay, like that. Okay, so that we can understand, because it's in here, we need to understand their physical properties and their chemical properties. Okay, what are those? Extrinsic properties, extrinsic properties, intrinsic properties, intrinsic properties. For example, if you need to boil the water at 100 degrees Celsius, we make coffee, something like that. Okay, so boiling is a phase change, meaning to say from liquid to gas during the process of evaporation, something like that. So that is also one of the properties, the boiling point through heating, and also the melting point from solid to liquid, freezing point, something like that. But those are properties. Not limited to that also, for example, the density, viscosity, okay, surface tension, and everything. Ganon. There's a lot of properties, okay? And then we can also mention the amount of the substance, the length, the weight, the mass, the volume, the pressure, the temperature, something like that. Okay? So, machine tabo. Okay? So, if they are in the group, they will normally share the same properties. Okay? If they're in the family, so we cannot assume that they have the same properties. Okay? Like this. Okay. So if you have the periodic table here, assuming lang niya ito because gamay na kaya akong word. Diba? Ganon. So, ano rin ka nga, okay. Dapat na siya mga group 2, dili, group 2, group 1A, group 1B, group 2B, 3B, Group 4B, Group 5B, Group 6B, Group 7B, and there are 3 Group 8B, okay? Something like that, okay, in the periodic table. So there are, I think, 18, 1, 2, 3, 4, 5, 6, 7, the group, 8, 9, 10, 11, 12, 13, 14, 15, 18, okay, something like that. Okay, the group, mga grouping, chucho. Okay, ito nasa center, guys, usually, nakapag siya mga transition elements, okay, transition elements. Okay. And then, sa group 1, yung mga palangga mo na siya mga alkali. Okay? Alkali metals. Alkali. Okay? And then, the second group 2A will be the alkaline earth metals. So, we have alkaline solution. Okay? Soda lime. Ganon. Soda ash, mga soft drinks. Okay? Belong to the alkaline naman siya soda. Mga sodium, chupa-chucho. Okay, sodium hydroxide, calcium hydroxide, mga ganun. Alkaline, earth metals. Naman din ang mga kung ano mga palangga, mga magnesium, calcium, ganun. So natin mga calcium hydroxide, okay? Mga lime water, ganun. Soda lime. So, hindi na siyang bilong dito. Okay? Then, we have the group, let's say, 4A. Ang sabi na siya kapag mga carbon. Okay? Carbon. Okay, wako ka memorize sa carbon ang siya ang bidaan ng group 4A. And then group 5A na siya yung phosphorus o nitrogen. Bali akong introduce yung mga sikat na kaayo. Okay. Group 6, oxygen, gano'n. Sulfur, nakalimutan sa ubay-ubay inihita yun na. So, selenium, beryllium, gano'n siya. Okay? And polonium. Okay, ako gibukas ko tayo ang group 6A. Kailangan kayo sa group 6A. Paano mo siya octet rule? Okay? Dahil na nagkakila ng oxygen. Okay? And then ang group 7, ako gibukas ko tayo fluorine, bromine, iodine, astatine. Ganon. As ang group 8A or group 0, ang noble gases. Okay? Noble gases. So, stable siya ang noble gases man. So, di ba? Helium, neon, okay, argon, okay, krypton, xenon, and radon. Ganon. These are noble gases and reactive. Okay? So, based on this, we can judge the ionization energy, the atomic size, the melting point, the boiling point, the electronegativity, the ionization energy, the electron affinity, the chemical reactivity, the flammability, the flash point, the density, surface tension, density, atomic weight, atomic mass, mass number, okay, ganon. Relative mass unit, atomic mass unit, AMU, something like that, and the rest. Okay, so prove this. Okay, so that we can arrange properly. So the group 7A is the, the halide group. Group 8A or group 0 is the noble gases. Okay, and group 6A. Okay, we don't have the name for this, but usually these are stable under octet rule. Okay, itong Lewis dot structures of chemical bonding, right? Okay, and phosphorus and nitrogen also. But somewhere along here, guys, ito mo na siya mga metalloid. Okay, ito mga germanium, ana, silicon, sunod na yung mga carbon na siya dito, di ba? Okay, so mga ano na siya, mga colloid, metalloid. What is a metalloid? Now I will ask you, what is a metalloid? The metalloid can act as a metal, sometimes can act as a non-metal. So sometimes can act also sa solid, sometimes can act as a liquid at a certain temperature. Something like the mga dual properties, mga metalloid. So if you try to consider that the human beings, so these are, bisexuals, like that, okay, homosexuals, not heterosexuals, okay? They will exist in either way, a boy or a girl. Like that. Metalloids also will exist as a metal or a non-metal. So it's not only for human being, it's also applicable in the matter. Okay, the kind of orientation. Okay? Not only for sexual orientation, but also for the elements. Okay? Especially, for example, so water. Water also will exhibit an amphoteric property. Amphoteric can act as an acid, can act as a base. Okay? Nasa siya dual property ang water. Okay? So, in everything in this world, naji duha-duha. Okay? And that is a natural process. Okay? Ganon. Okay? Muna mga metalloids. Sa tupa, ano siya mga guys? So, element, okay. Element composed of metals, non-metals, and metalloid. Ganon. Okay, again, elements composed of metals, non-metals, and metalloids. Okay? Usually sa mga metalloids used in semiconductors industry, sa mga electroplating industry, sa mga electroplating of the covering of the cell phone, of laptop, appliances. If you try to coat that one by a certain metals, so we need to alloy, meaning we need to combine different metals for that. And because metalloid is very, is very flexible, most of the metalloids will do that. Okay, not the metals, not the pure metals. Most of the metalloids are used in semiconductors industry. Okay, that's called semiconductors because they're using metalloids, not the pure metals. Metalloids can act as a metal, can act as a non-metal, so very flexible. Sometimes can conduct electricity, also will not conduct electricity or poor conductivity of electricity, and sometimes also a little bit higher, something like that. Ano din siya guys sa mga properties ng mga metalloids. Ganon. Okay? Now, kung elements naman tanong, so dito kami sa mga compound. So, okay? Ganon siya. Okay. Now we go to the other property. Pagpunta sa kuan. Electronegativity. Okay? Ganon siya guys mga palangga. Okay? Natuto kayo ko. Char! Tapos yung mga atoms. Okay? Now, our next topic we need to discuss what is an atom, what is a particle, what is an ion, what is a molecule, what is a mole, okay? And the nucleus, something like that, okay? So parang 6 lang siya, di ba? So we can differentiate what is a particle. We can differentiate what is an ion, what is an atom, what is a molecule, what is a mole, so that we can differentiate during our stoichiometry, chemical calculations in the problem solving, so that we can really understand, oh, it's going to be like this. So we can compute already what's being required because we understand properly. Oh my gosh. Okay. Ganon. So we have first the ion, the atom, the molecule, the particle, okay, the nucleus. Ganon. Okay. What is the ion? Anybody? Parang ganon. Natututo ng chemistry. What is an atom? What is a molecule? What is a particles? Ganon. What is a nucleus? Okay. Okay, nucleus is the central part of your atomic structure. Central part in the center. Okay, like that. That's the nucleus. Okay. Inside the nucleus, we have the particle called the nucleons. Okay, in which the nucleus also have the nucleus, something like that. Okay, and now for the ion, these are all about positively charged ions and negatively charged ions, something like that. Okay, with the meaning of ion, we say the element has been charged already. Positively charged ion, negatively charged ion. Positively charged ion is cation, negatively charged ion is an ion. So charge equals zero, then we can produce this kind of ions. Okay? And then, how can we do that? Okay? We need to react that with water. Okay? For example, not for example, specifically talaga siya, metals and non-metals. Okay? Metals positive, non-metals negative, so we have, opposite charges. And then, we produce an ions later on because we add water, we add different kind of solvents, organic solvents, organic solvents. If there's no addition, then it will just remain a compound, neutral compound with a charge of zero. Okay? If we do something, then that's the time charge will be coming in during the solution, mixture, chemical reaction. Meaning to say the ions are mainly the result, impact, yield. So it will never come easily if you do nothing. Something like that. You get the point. So for example, the Arrhenius theory of acidity and basicity. For Arrhenius theory of basicity, we need to yield hydroxide ion. Okay? And then for Arrhenius theory of acidity, we need to yield a positive ion, the H plus ion, or what we call also another version, hydronium ion H3O positive one. Okay? But without addition of water or any aqueous solution, then it will never charge. It will remain neutral. For example, metal, magnesium. Okay, magnesium. Oh. So, and then oxygen. React with oxygen, right? So, if you don't add water or any kind of solvents, then the magnesium here is just neutral, not yet charged. So, when you say the charge is zero for magnesium, oxygen also the charge is zero. So, if you have the charge is zero, this represents a neutral charge, then it is specifically called a neutron. With the point, if the charge is neutral charge, it is the neutron. Okay. Because the positive positron, the positive proton, and the negative electron will not appear every time naturally. Okay? With the point, so in an electrochemical configuration basis also, they will just occur in the excited state. Okay? In the Niels Bohr theory and the John Dalton atomic theory. Okay? There's a big atom, something like that, ganon. And there's a nucleus like that, blah, 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 so and so. And then if one electron will occupy in the first energy level, it will not be excited to another level. Okay? So there's no charge pa. Di ba muliyok-lihok ang mga electron. It will just be activated if it will be in the excited state. Ganon. So the root word is excite, and then it will become activated, it will become excited. With ED. Okay, the root word is excite. Okay, I think that's verb, right? Excite. E-X-C-I-T-E. And then after excite, the process of exciting with each other, that is excited. The ground state and the excite state. Ganon. So the ground state meaning natural pa siya, wala pa siya mulik-lihok ang mga particles. Ganon. Hindi kung maglihok na siya, ma-activate na siya, mulokso ulit siya. Ganon, sa second level. Lokso na po siya sa third level. Ganon, matutuyok siya dito sa circle galore. Okay, sa atomic structure. Di ba aligre, mag-jump sila dito, maglangoy-langoy sila dito sa kuan. Ganon. Okay? So muna na yung tabor ito, magdaduwa sila. But si ang jowa niya ng higayuna si kuan, manag-uyab ni si proton o si neutron niya. Kani si electron, magkabit rin ni siya. Okay? Because kani si proton si neutron uyab, manag-asawa, sud sa usa ka nucleus, ganon. So, proton ug si neutron manag-uyab. Okay? Dikit kini silang duha kay naman sa center sa nucleus, proton and neutron. And then si electron to sa gawas nagtuyok-tuyok siya. Okay? Because negative man siya, meaning light siya. I-compare sa proton ug si neutron. Magkasinabot si proton ug si neutron kay almost the same man silang masses. Okay, mga 1.67 times 10 to the negative 27 kilograms, more or less the same, protons and the neutrons. But si electron, lighter man siya because he has a mass of 9.109 times 10 to the negative 31 kilogram. Okay, oh, imagine how light the electrons is. That's why the electron will always occupy in the, outer shell, not in the center of the nucleus. Okay? That's yung mga ionization energy, electrophoretic, i-pull man si electron sa center, sa nucleus, para na mahitabo ng mga reaction. Because if there's no pulling of electrons, then there's no also giving of electrons, then there will be no reaction. Okay? Something like that. Dito point mga palangga, kung siya may tabo. Charot! Okay. Okay, what is an atom? Charot. Okay? An atom is the tiniest and the smallest particle, okay, inside the nucleus. Mga ganon. Okay? Ganon siya. What is a molecule? Composed of two or more atoms adjoined together or combined together to make up a compound. That is a molecule. So specifically molecular compound. Okay? Like this. You get the point, mga palangga. Okay? And then particle. What is a particle? Particle is an elementary particles called electrons, neutrons, protons, positrons, mesons, baryons, photons, and a whole lot more. So these are particles. Meaning discrete particles that cannot be seen in our eyes. Something like that. They can only be seen through microscopy technology. Looking in the microscopic technology, or let's say having the spectrophotometry absorption technology, in which you just watch that in the monitor of the screen, how the electrons will move in the monitor of your computer, but you cannot see directly in your eyes. So these are very, very, discrete particles, elementary particles that we cannot see. Okay? Ganon. So electrons, protons, neutrons, positrons, photons, mesons, baryons, ganon. There's a lot of elementary particles. Because you have also the sub-elementary particles. This is particles, sub-elementary particles, sub-elementary particles, until it will just become a very tiny, tiny particles that we cannot describe already. What's the name? Charot. Okay. Now, muna na siya. Nucleus na. Define na nato tanan. Okay, muna na siya. Okay. Okay, ganon. Now, mubalik ta dito sa katungkuan. Mga properties. Pero yun na lang guys, sa katugon na jugay ko guys. Okay? Kung mo ko katuga, kailangan pa ko mag-vlog. Charot. Okay. Matulog na ta ka mag-alas 2 na siguro guys. Okay. Salamat kayo sa pagtanaw. Alam mo, Gretel Bacalso. Okay, Zupal. Murag ko naman siguro yan. Alas 2 na no. Oh, alas 2. Alas 7 sa buntag. Diba? Okay, muna siya dito. Okay. Ako sa siyang papaso. Okay. But before I end, guys, I need to illustrate the, what's the name? Okay. The illustrate ng mga atomic masses, ha? Okay. So, for example, so based on my memorization when I was in high school, okay, hydrogen, ganon. So this is 1.008 gram per atom, the atomic mass or the atomic weight of hydrogen. And then we have the lithium, okay, Li. So you should also memorize the symbol also. If you love chemistry and you love to take up BS chemistry, if you want to become a chemist, or if you want to become a chemical engineer, then you have to memorize also the symbols, okay, the atomic masses, something like that, and the properties that I mentioned and discussed a while ago. Okay, so we have the lithium 6.94. Okay, and we have also the sodium, okay, 23.99. Okay, muna siya ang sodium, or let's say 23 lang siya. Okay, and then we have potassium, 39.1. Okay, we have the strontium, 85.47, ganon, gram per atom. And we have the cesium, 133, ganon. And we have the francium, okay, which is 223 grams per atom. And then based on my research, okay, I researched that, last month, okay, we have another element being discovered in 2018, okay, what we call as the organeson, specifically the unonium, but it was not fully synthesized yet. That's why it's not reflected in our textbooks now. So if it will be fully synthesized, We have now already 119 elements. But as of now, we have 118 elements pa, officially. But later on, we don't know, it will become now 118 because it's still under process, this one element discovered in 2018. Okay, ganun siya. And then, diri dayon, sa sunod, muna na siya ang kuan, ang beryllium. Ciao. Beryllium, 9.01 to mga palangga. We have the magnesium, okay, 24.30. Calcium, 40.08. Ganon. Then we have also the, the strontium, okay, rubidium, okay, okay, strontium 85.47, rubidium 87.62 ang strontium, 87 ang rubidium, ganon. And then we have the barium, okay, 132.327, okay, and we have the radium. Radium is a radioactive element, radium. Okay, so it will undergo the process of, radiation. It will emit particles, something like that. Okay, radiation. So ito mga particles, ito mga alpha particle or alpha emission. Okay, may image yung mga rays, chupa-chuchu. Okay, beta ray, gamma ray, gano'n. Okay, like that. Okay, and then the radium will be 226. Okay, and now we have here, okay, carbon 12. Okay, boron 10.83, silicon 28.28, aluminum 26.98, ganon, phosphorus 30.97, okay, oxygen 16, ganon, the most common, right? Okay, sulfur 32, ganon, and then we have also the selenium 78.96. We have beryllium 127.6. We have astatine 210. We have the bismuth 208.98. You have the polonium 209. Okay, then. Okay, arito sa mga halogen. Fluorine 19. Chlorine 35.5. Okay, bromine 79.70. Okay, iodine 126.90. Okay, ganon. And then we have the helium. Okay, the second most lightest element, helium. Okay, it's gonna be 4, right? Okay, 2 and 4. Tama ba? Yes, atomic number ang 2, mass number ang 4. Correct me if I'm wrong. Okay. And then we have the neon, 20.18 grams per atom. And then we have the, argon, 39.95. We have the krypton, okay, 83.80. And then we have the xenon, 138.3. And we have the radon, 222, the triple 2. Okay? Ganon. And then we go to the metals. Okay? We go to the metals, mga palangga kong hitad. Okay? Sa mga metals, chuba-chuchu. Ganon. I love gold. Okay, gold. Precious gold. AU is equals to 197 grams per atom. Okay, silver, 107.9. Okay? Then cadmium, 112.4, ganon. Okay? Mercury, okay? 200.6. Okay? Lead, 207.2, ganon. Okay? We have the copper, 63.55. We have the zinc, 65.38. And we have the nickel also as well. We have the 98, okay, 0.69. Okay, kita po yung mga palangga. Okay, 83.69. Okay, and then we have the chromium, 52. Okay, flat siya. Okay, and then manganese, 53.93. Okay, cobalt is 58.93. Okay, cobalt, right? Yes. And then the nickel, okay, the nickel is 58.69. Okay? Okay, magduol naman si cobalt ug si nickel. Okay? So 58 mo na akong itimanan sa akong memorization. 58.69. Tama ba? Tama ba guys? Okay. Tama siya. Okay? Ganon. Muna si cobalt. Okay? And then we have the iron. 55.85. Ganon. Ganon tayo manganese. Oh, okay na siya. Okay? What else? Itong na-list up. Okay. We have the tungsten. W. Tungsten, 183.8. Diba? And then we have the antimony, SB, right? This is gonna be 1 to 1.8. Okay, we have the antimony, SN 118.7. Okay, and then we have also the promethium, the only radioactive element in the actinide series in the periodic table. So, promethium, 145 iyang atomic weight. Okay, like that. And then we have the uranium. Okay, radioactive element kaya po siya mga palangga. So, 38. 238. Plutonium, 244. And then we have also iridium. Iridium is IR, right? Okay. Iridium is 192.427. And then we have also platinum. Okay, 195.084. And we have the palladium. Okay, 106.42. Okay, a total of 60 elements. At least. Okay? Muna inyo siya i-memorize samtang yang pang atong brain cells. Charot! Ganon. So, master na ito ni mga stoichiometric relationship, how to compute the empirical formula, ganon-ganon, chuchu-chuchu. Okay? Chemical formula, empirical formula, percentage by mass, percentage by volume, ganon, di ba? Nakaloba. Okay? Ito po yung mga palangga. Muna na siya. So, bye-bye. God bless everybody. Kaya matulog na si Junjun. Bye-bye. Oh, di ba? Nakakaloka. Oh! Charot! Hi guys! God bless everybody. Katugo na kayo ko. Nakuing.